recording. Okay, so what I wanted to go through today is the process of refactoring basically the code that comes out of Blockly.
Nice, that sounds good.
In Haskell. So what I'm going to do is, well, I'll show you, right? Like, so if we look at the Escrow Contract as one of the examples there, you know, they've got it nice and factored out in Haskell. So the contract kind of reads.
It's easy to read in code.
Yeah, as it's shorter, right?
Yeah, cleaned up.
So what I'm going to do is basically start with this same contract and go through the steps that I would take to end up here, right?
From any contract.
From any contract, yeah. So it may not end up exactly the same, but it doesn't have to end up being exactly the same as long as it's clean and tidy.
Yep.
So my goal is just to start off and just go through the process of doing it, and you ask me questions as we come along, and I'll kind of tell you what I'm doing and why I'm doing it and so on. So
Sounds
we'll
good.
start off with something like this, right? And we'll go into the Haskell editor, and I'll get rid of all of that and just say contract equals paste. So as it stands, that should compile. And yeah, that compiles. So we've done nothing other than paste it into Haskell so far. So the first thing I see here, right, is that whenever we're talking about an Ada or a Lovelace, it's this token with 2 string parameters. So the Haskell library from Marlowe actually already provides you a value called Ada. So instead of token empty string, you can just write Ada in all of these. That's kind of a special one that's provided to you by the library that you have to define yourself. So you could have said Ada equals token empty string, and then just start replacing it.
Gotcha.
But that's going to complain that ambiguous occurrence Ada could refer to either language.marlowe.ada or escrow.ada. So I'm just going to talk to you about this error message a little bit, just to kind of, so it's not completely, you know.
I gotcha.
It's not completely like terrifying. So we have a module here called escrow, and this module is just something that we call our smart contract, right? So notice that it could ambiguous occurrence Ada, it could refer to either to language.marlowe.ada or escrow.ada, right? So you notice that we've done this import language.marlowe, which we're going to need to do everywhere because that defines things like token and when and everything from Marlowe. But like that's different modules. So right, like somewhere in the Marlowe code base, there's something that says module language.marlowe, and then it's got a bunch of definitions like here. Just like here, we've got a module escrow, which has a bunch of definitions.
Yeah.
So what it's complaining about is that there's an ambiguous occurrence because it could be the imported one or the one that we've just defined.
Gotcha.
So easiest thing is just to not define it because they mention Ada. So
because Ada is the currency of the blockchain.
Yeah, that's why they supply it. So I'm just
so unless you're defining a native asset on the blockchain, then it's always just going to be Ada.
Yes, correct. Mind you, this definition is still fairly, so that should compile now, is fairly, like you could define it yourself. For example, if we go, well, that terminology is wrong, we actually want to call it Lovelace because that's what it actually is. You know, an Ada is divisible, whereas these units that we're talking about are really not.
Yep.
You could just say token empty string like that. It's the same thing, and then put it there. So it's up to you what you want to use. But I'm going to use the ADA because that seems to be somewhat idiomatic in this. The other thing is, yeah, so that was ADA. Okay. Now the next one I want to do is choice. Okay. So when I look through this, there's a lot of choices, right? Alice's choice between 0 and 1, and then Bob's choice between 0 and 1. And then more references to this choice value of choice. And then yet another choice between 0 and 1.
Gotcha.
You notice like this one's between 1 and 1, sorry. So they're a little bit different, right? But
every option's presented.
Yeah, but they're also like there's a lot of similarity between them. If we just look at Alice, like this one here and this one here, right? They're very similar. So the name of the choice is choice. And then, this whole choice, like the only difference is this one's for Alice and this one's for Bob.
Gotcha.
So let's
same choice, just different role making it.
Yeah. So I'm gonna start real simple. I'm just gonna say Alice choice equals basically that, right? So there's an airplane flying overhead.
That's all right.
Cool. So yeah, I've written that Alice choice there, and then now we can just say Alice choice in here. So that should still compile. Now, so that's still compiling correctly.
Yeah. Yep.
Excuse the dog barking.
No worries.
Okay. And the next thing we're going to do is like do the same thing for Bob choice, which is this guy here, I believe. So
so I see I'm starting to track now. So what you're doing is really, instead of that block, now fattening up this document multiple times, you're really consolidating it to one line of text.
Yes.
In the contract.
Yes, exactly. So you're kind of you're basically reducing duplication because instead of repeating everything each time you refer to it. And I'm just tidying it up here a little bit. It's up to you whether you want to use multiple lines or I think single lines for these things are quite nice.
And what drives that preference?
Good question. It's kind of an aesthetic decision based on readability, right?
Gotcha.
So, like, I largely do it by intuition. I don't actually have a rule of, but basically, if you got too many things on a line, then it becomes overwhelming. So you split it across multiple lines.
Gotcha. It's kind of like a ruler almost.
Yeah. It's just, but the same way as you might split a long sentence into a set of bullet points, right?
Gotcha.
But at the same time, you can go too far and provide a bunch of bullet points for something that are basically one sentence can more concisely explain. So it's largely intuitive, but I think like probably, like this is around my limit of what should be in one line, but yeah, it's kind of one of those aesthetic choices. The other thing I like to do is kind of line things up as much as I can, just so you can see their similarity. So we've done almost nothing, right? We've just we've just moved some inline definitions to their own definitions, right? And the key thing that's a general principle of refactoring is that you don't actually make changes, right? Like the contract functions the same way, but you've changed its structure. So
Yep.
refactoring or restructuring, same kind of concept. So I just want to really stare at these two, because even though we've pulled them out of the same contract, there's still quite a little bit of there's still quite a lot of repetition here. For example, there's this string choice and choice, well, we can give that a name. Choice name equals choice, and now that, that's just choice name now. And again, that may, we're not actually making anything shorter, and in fact, in this case, we've made it slightly longer. But the advantage here was, now if we wanted to rename this choice, we would only have to do it here instead of in both of these places.
Instead all the different places in the document.
Yeah. So that's kind of, it's not so much always about length and readability, although that's a factor. It's also about what we call maintainability, the ability to change things without accidentally introducing inconsistencies and things like that. So
yeah, if you had thousands of these choices repeated in here, instead of having to update all 1,000 of them, you can update. Yep, I gotcha.
Yeah. So what we're going to do, now is basically find everywhere that uses a choice string and just replace it with choice name. So see, we've got 10. So I'll just write choice name here.
These are the kind of things sometimes that are scary for me when I'm doing just normal web development, and then I, go to test something and
Yeah. Well, this is the reason, none of this is Marlowe specific. This is a general refactoring. But the reason is that, especially names of things, things like numbers of things as well. How many, when you're choosing one of n, you want to be able to change that n without, going all over the place. We're nearly done. Choice name. I think we're done. So now if I search for choice, it should be in one place. Cool. Okay, so still compiles. I hope. Yeah, it does. Okay, next.
That's what's so great about this playground, is that testing it real quick to see if it compiles and all that. That's pretty cool.
Yeah. I mean, that's what's good about it, and that's kind of that's what languages like Haskell give you. So obviously there are lots of other languages that are compiled, but Haskell has a good, quite a good type system where a lot of cases, if it compiles, then it works.
Yep.
And there's a huge advantage to that. Anyway, so we may be dwelling on this a lot, but there's actually these two lines are still very repetitive. Because if we look at them now, basically they only differ in Alice and Bob. Everything else is the same, right?
Yeah.
So what we can actually do is make a function that builds up, takes a parameter of that name, and then builds up this whole thing for that name. So I can call it choice, and it takes a parameter called name, and we'll paste this, and instead of Alice, we'll write name here. And now now it reads quite nicely, right? So we've just moved that choice Alice from hard coding Alice to taking a parameter. And now to define our Alice choice and Bob choice, we just say choice Alice and choice Bob.
Now, I think is what you just said there. So this would be a way then to make this dynamic so that these
Exactly.
like
Yeah.
so Bob could be John or
Yeah.
Alice could be Jenny, and update all the different places in the contract where Bob and John and Jenny and
Yeah.
Alice go.
That's right. That's right. That's exactly it.
Yeah,
So
awesome.
what we've done is we've gone from a simple value. I'll just Control Z a few times and show you where we were. We were here, which was hard coded. It was still a value on its own, which is nice, but it was
Still a lot of hard coded information.
Yeah.
Not dynamic, really.
Yeah. And we changed, and instead we made a parameter here, name, and we passed the name in here.
Very cool. Yeah, I like it.
And then that one just becomes choice Alice, and that one becomes choice Bob.
This kind of really just opened up my eyes to how you would really take a contract with hard-coded information and turn it into something that someone could input that information through a form.
Yeah. By all means. And if you like, towards the end of this, we can, rather than having these things in here, we can actually take them as a parameter so that they're passed into this Haskell program,
Yeah, I think that's so cool to you know, the whole idea of passing parameters to really be able to, I mean, at the end of the day, these contracts are always going to be kind of individual in some aspects every time, depending on who's executing the contract.
Yeah. So that's the whole advantage of using a programming language for this over, building it with Blockly or something like that, because you can do these things. You can introduce parameters. You can, you can vary things.
The cool thing though is, I mean, you could someone maybe not like me, not as well in Haskell, but someone who's maybe could become very proficient in Blockly could create a Blockly contract and pass it on to someone like you who could, just do
Tidy
this.
it up a bit, yeah.
Yep.
And that's it. So you can have this, yeah, exactly. So you can have and I think for me, it's for the time that I've spent playing with Marlowe, I found whipping something up in Blockly is actually really efficient. So I would actually recommend building up the basic blocks in Blockly and then bringing them into Haskell and parameterizing them. In Haskell,
it's so cool how these work together in here, where you can pass it in between the different areas.
Before we finish today, let me show you the new JavaScript editor that showed up to. So yeah, you can do this in JavaScript as well as Haskell now.
Very cool. I did catch something about that from the Wyoming hackathon that was a new feature in Marlowe. So that's very cool. That's going to really open this up.
It's like a one-for-one mapping, and I think a lot of people are going to use the JavaScript editor over time because Haskell is daunting for a lot of people. But I think neither choice really gains you anything. Haskell has the advantage that you can paste into Haskell one of these things and it works. Whereas the JavaScript one, you can't do that. You have to change its form before you can even write it. So
it was a very cool addition to the playground, though.
Yeah. Cool. I will, when we're done with this, or when we run out of time, then I'll briefly show you how you might write some of these small things in the JS editor just to convince you that it is the same.
Cool.
The same thing. Okay. So the next, one more thing I want to do. So I've been just writing choice name equals choice. Choice, so I've been writing these values and functions, and I haven't really been writing their types. And for me, at least, when I'm writing Haskell code, I find writing out the types really helps a lot. So, for example, what's a choice? Well, if we go into Blockly, choice is an action, right? Because like a stupid way of thinking about it is like, but it's kind of a useful way of thinking about it as well. Is that it's in the actions menu, so it's an action, right? So we can write something like Alice choice is a choice as an action, and Bob choice is an action. Right.
Yep, I'm tracking.
So far, nothing weird. We've just said what they are. And so now, what's this function here? Well, it takes a parameter of something. These look like strings, so I'm gonna write string to action. Right. And we're gonna get an error because this is actually not a string. And we'll get to why, but I just want to show you the process I go to, because it's a little bit, working in this playground, you don't have direct access to documentation, so it can be a little bit hard to tell what the types of these various values are. So just so you have that in mind, it'll tell me an error saying could not match type char with ledger value token name. So remember, char list is actually a string. So string is the same as char list. But it's saying, no, you gave me a char list, but I wanted a token name. So I'm just going to do what it says, and instead of strings, everything else is the same, but I've just called that token name instead of string, because that's what the error message told me to call it.
Okay.
And I think it's going to complain again. It says, not in scope, constructor or class token name. And I'll show you why. I'll go back to string just to see the previous error. So it's saying could not match type char with ledger.value.token name. So what that's saying is it's looking for a type called token name in the module ledger.value. So the last thing after the dot is the name of the type, and everything else before the last dot is the name of the module. So what I'll do is import ledger.value. And then by importing it, token name becomes available. Right, so yeah, so anything, like if it's saying I want this library and this name, you can import that name. So at the moment, anything in language.marlowe is already imported. Now we have a ledger.value as well. So now token name to action should work. It's just a typo. Yeah, so that worked.
Nice.
So this is a little bit strange to me, because a role name shouldn't really be a token name. It should be called a role name, but for some reason they use a token name here. Now, the other thing I wanted to just briefly mention is, so choice takes a token name, but here we've given it a string. So how does that work? And the way it works is this kind of automatically gets brought into the top of all your Haskell editors in the Marlowe playground. So overloaded strings basically means that for any type that, like, certain types can be written as strings even though they're not the same thing as a string.
Okay.
So this token name type defines that it can be written as a string. And if you've got this language extension turned on, then you can write Alice. Otherwise, we'd have to, do something like, I don't know, token name
Oh, I see what you're saying.
Alice or something. We'd have to do some kind of way of converting it, and we could look into that. But basically, by having overloaded strings, you just have the string there. So that may or may not have come up in your thoughts, but certainly it was confusing for me when I started working with this stuff. So that's where it comes from. That token name allows overloaded strings.
Gotcha.
Cool. So we're nearly finished with choices. Well, we're half finished, right? Because we have the choice actions. We're also going to have to look at these choice values. But before we do that, there is one more choice, which is Carol's here. But that one's a little bit different. Like the others gave us a bound of 0, 1 in both cases, whereas for Carol's choice, we've got a bound 0, 0 here and a bound 1, 1 in the other case. So this function choice isn't quite good enough because that always hard codes a 0 and a 1 here.
Gotcha.
So what I'm going to do is add a second parameter called bound.
You might be getting to this, but this just popped in my mind when you're saying that. So what about in the choice we have right now, bound 0, 1, don't Bob and Alice also have a different choice that's not 0, 1? Or was that the only
I think
choice?
So, I mean, what we're doing now is adding the ability to vary that choice depending on where it's used.
Gotcha.
But to answer your other question, no, in this particular contract, they both had a choice of 0 and 1.
Okay, gotcha.
That's
okay.
just how we can look in the Blockly. Can we? Escrow sent to Blockly, right? So if you look at choice for Alice was 0 and 1, and then choice for Bob was 0 and 1. So they happen to be the same.
Oh, that's right. Okay. Yep.
But then Carol,
the escrow.
Yeah, the escrow case, she chooses either 0 or 1 depending on.
Yep, I see now
what she's doing. Yeah. So we're going to do the same thing. So in the Haskell editor, basically I'm adding another parameter here, which is going to be bound, which is going to be the bound. And then that's going to take a bound here too. So first parameter is a token name, second parameter is a bound. And then instead of hard coding it here, we'll write bound. You notice this bound comes in these square brackets, which means it's a list. And to be honest, I have no idea why you would have multiple bounds for a single choice. So I'm gonna pass just one to choice, and then that's gonna pass a list of that one to the choice constructor finally.
Okay.
So now for both Alice and Bob, we have to write bound 0, 1. Like that. So that should still compile. Yeah,
yep.
So far so good. But now let's look at Carol. So let's see what we're actually doing. So when Carol, actually, let me just look into the Blockly editor because it's easier to. So when Carol chooses 1, this is if. Okay, I see what we're doing. So if Alice and Bob agree, then let's just have a look at it. So Alice makes a choice, Bob makes a choice. if they agree, and if Alice's choice is 0, i.e. the same as Bob's also, then we pay from Bob to Alice. Okay. So this is that escrow that we talked about. We did a
Yeah, and then when they disagree is when Carol gets called into the.
So if she chooses 1, then no payment happens, and if she chooses 0, then
Bob gets paid.
Bob gets paid. Okay. So we're going to call 1. We'll call that Alice choice no pay.
Yep.
And
yep, that's easy to remember.
0, we'll say Alice choose pay.
Yep.
So I was looking for names. Names are important. So
I think it's so helpful.
So that's an action.
It took me a couple website projects to learn that I needed to just name things what they meant or did.
Yeah, very much so. So I believe it was that was no pay. 1 was no pay, I believe.
I think that was pay. No, I think I can't remember now.
No, 1 was
no pay,
and 0 was pay. Yeah. So no pay was 1. Sorry, and that's Carol. Carol choice no pay. And then we can do the same with 0s. And we could refactor this further. Like we could.
You still got to update the names of the choice.
Yeah, but I think at this stage, it's kind of okay. So how deeply you refactor is kind of your decision based on aesthetics, and you start getting a feel for it. So I'm just going to make an executive decision here to not try and pull the common functionality out of this, but although by all means you could. So we could have like a Carol choice, and it takes an integer, which is a bound, but I'm just going to leave it like that. So Carol choice pay, Carol choice pay. Okay.
There we go.
Yeah, cool.
Yeah, I see what you're saying. It makes a lot of sense.
Yeah. So again, you choose how deeply or how shallowly you refactor, and over time you start developing a feeling for it. Anyway, now when we go to, so now this is Carol choice no pay, and this is Carol choice pay. And I'm just gonna tidy it up slightly like this, just so it's clear that that when we've got our case, when she chooses no pay, then we close. When she chooses pay, then we pay. So that should still compile. Perfect. Okay. Now we're going to talk about choice values. So a choice is an action. So in the Blockly editor, it's one of these things.
Yep.
The other way we recur to a choice is when we look at these values, and here's a value, right? For example. So yeah, like one is the action of making a choice. The other is looking at the chosen value. So I'm going to stick with the word chosen. So we can say Alice chosen. And that's basically. So when Alice makes a choice and then Bob makes a choice, and there's this thing called a choice value. So I'm gonna say Alice chosen here, and that's remove the outer brackets, put it on one line. So the type of this is a little bit tricky, but I'll just write it down. It might be something you just have to remember. I mean, I like telling you how you can figure things out, but once in a while I get. So my first thinking was value, that it's a value, and the thinking from that was because it came from here, and that's half true because it is a value, but ambiguous. Oh, that's painful. Okay, so I've got one of these ambiguous occurrence, basically because when I imported ledger.value, that contains a value called value in there as well. And all I really remember, the reason I imported that is because I wanted that token name. So you can say, don't import everything, import just these things by putting some brackets after the import and say token name here.
So you can pick to import one thing from that.
Yeah, or as many as you want, you know, like comma, comma, but rather than everything. So this way, this imports everything from language.marlowe, and this only imports token name. So
interesting, gotcha.
If you get these ambiguous occurrences, that means that I guess one of your imports should be less promiscuous, like and more selective about. Okay, so this is the expecting one or more argument to value expected a type, but value has kind star to star. I can't teach you about kinds today, but its type is value observation. So I don't really, you know, whenever possible, I'm going to tell you how to kind of fix your own type errors, but in this case, like that error message it takes more Haskell to understand.
Oh yeah, no, I understand. Yeah, I don't need the details on
just remember that the type of a choice value is a value observation.
Yep.
So that's like, yeah, just like that with a space in between them. Cool. So right away, I'm just gonna make something called chosen, and it'll take a token name. So same thing I've done before, just taken one of these and parameterized it by the name. So now Alice chosen can be equal to chosen Alice. Yeah, same that we did with choice, I did it with chosen. So just gave it a parameter.
Gotcha.
That should be okay. Cool. You notice I'm compiling all the time, and that's a good practice. Like keep compiling. Don't write a whole lot and then try to compile like later and get overwhelmed by the number of errors. So just hit that compile button all the time.
Yeah, makes sense.
So cool. Now we can talk about. So if Alice chosen is equal to, I'm just trying to match up the brackets. I think that's it. Bob chosen. We have to write Bob chosen. So again, not all of these things need these types written out, but like, because Haskell's quite good at figuring it out itself. But when you're starting out, I think if you write the types, then your error will be less confusing, because it'll tell you, I expected this type, but I got that type. If you allow it to guess, then what can happen is you use the wrong type elsewhere, and the place where it tells you use the wrong type here, it's hard to figure out. You have to kind of trace down a longer
Gotcha. That makes sense.
things. So I think writing your types down most of the time is good practice. Some people disagree, but certainly when you're starting out. And yeah, cool. So we got Alice chosen, Bob chosen. What else have we got? Okay, so yeah, if value Alice chosen and Bob chosen, if they're equal, then if the Alice chosen is equal to 0, so that's Alice chosen, then we pay. Otherwise, when Carol chooses no pay, then we close. Otherwise, Carol chooses pay, and we pay.
Yep.
Pay there. So you notice that pay is the same here and here. So that's another thing that we can refactor out. So that guy there. So that's the payment, right? Payment. Actually, this one I'm going to leave a little bit in multi-line indented, because I do intend to tidy it up a little bit more. But so that should be fine, and then we can replace this pay here with payment, and also we can replace this pay here with payment. Right, so now this kind of reads okay, when Alice makes Alice's choice and Bob makes Bob's choice, if the Alice chosen value and the Bob chosen value are equal, then if the Alice chosen value is equal to the constant 0, then we do the payment, else we close.
Yep.
Else, when Carol chooses no pay, we close, and when Carol chooses pay, then we make the payment.
Yeah, it's very, very simplified to read if you know what you're looking for.
Yeah. Like, in practice, for someone to understand the contract, they're still going to have to look at these definitions. I think, you have to be really good with variable naming to avoid that. But I think still it's an improvement.
Well, I just like the whole this really enlightened me on the way that you take something from Blockly that is, static in maybe the roles or the amounts that you're going to enter, and this really makes it so that you can make those parts of the contract dynamic much more easily.
Yeah. So I'm just gonna carry on here because I can see a few things. So this was a Carol choice no pay. We already had one. This is just a repetition of that. Carol choice no pay. And then this one was a Carol choice pay. I'll move the case here. And this is the payment again. And then, okay, we're nearly there. So we'll get rid of all of these. So that's a Carol choice no pay. Move that back. That's a Carol choice pay. maybe that's a nicer way of reading it, like that. Something like that. And then this thing is payment again. Okay, so I've replaced a few things, so I hope I haven't missed any brackets. No, it's still compiled, so we're still good.
Nice.
So
Much more condensed and
yeah, it's getting there,
clean.
right?
Yeah.
We're still not at the example one, but I think like
I get what I 100% understand where you're going though with this.
yeah.
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 You know, honestly too, you know, I'm really kind of excited to see what you thought of that JS editor. So before I do, you know, we do sign off, if
Yeah.
I'd love for you to kind of show me how they are similar.
Yeah. Okay. So yeah, I'll do what I will do is I'll take a small piece of maybe a new small contract from Blockly and translate it into JS. Just I haven't tried doing it with anything complex yet, so
Well, even if you could just point out, you know,
yeah,
kind of what you've gathered from the
yeah,
way it's kind of laid out.
yeah, cool. So I'm just gonna this payment is also, you know, got a lot of hard-coded magic numbers and strings. So two things. First of all, I'll just finish with refactoring this payment, and then we'll stop here. I will send you the code for this, and by all means, you carry on with it and keep any contract we've worked on. Really, I think it would be a really good exercise for you to try and go through the same thing that we've just gone through on the video to practice it. Anyway, so I wanted to just say payment type. It's a contract. That should be fine. Yep. Again, I know it's a contract because it's pay is a contract here.
Yep. Okay.
Yeah. Most of the time, it's very straightforward what the type.
Really, the only one that's been different so far is just value having observation added to it.
Yeah. Exactly. Yeah. Cool. So the other thing I wanted to do is just make a little function so that payment can take some. So I'll call it make payment. MK for payment for make, and that will take from. We'll just say token name, take and integer, and it'll return us a contract, and it'll be so make payment from to amount equals. Jam that in. So let me just be a little bit careful here. So in Blockly, 2 comes first. Okay, 2 comes first and then from. Okay, cool. So Bob is paying Alice. So that means that is a 2. That is from, and that is amount. So now we can just pay payment is equal to make payment from Bob. Is it from Alice to Bob or from Bob to Alice? From Alice to Bob. Bob for 50.
Was it from Alice and Bob? What did it say?
Yeah, because from comes second. It's annoying, right? The payee is Bob, and from
Gotcha. Okay.
Account 0 is roll Alice. And let me just have a look in the Haskell editor. No, I'm wrong. Yes, in Blockly it's backwards, but here it's so that should be from. That should be 2. And then we're paying
Yeah, they're kind of reversed in the.
in Blockly only,
Yeah.
from Alice to Bob. Okay, so we're paying from Alice to Bob. So that should all be the same. All we've done is just made a little function so that payment takes a couple of names and an amount. So that should still compile. Everything should be the same.
Yep.
I'm just going to send it to Blockly so we can see it. And now you've got some advantages, right? Like, actually, we want this whole thing to be
5,000.
5,000. We haven't quite refactored everything. So let's say I'm just going to make it be like, remember that Alice deposits 450. So I'll just change this payment to 50 because it's got to be, less than what you deposited. Otherwise, it's
Gotcha.
not. So 50, right? Doesn't matter what the amount is. And obviously we can still keep refactoring and get this out so that 450 is in one place, but let's just make this 50. So that's just changing the payments to 50. Compile. Sent to Blockly. So deposit is 450, but then all of the payments are 50.
Yep.
Yeah. So useful, right? So we've got some, we've got some basic choices. Our names, Alice, Bob, and Carol, are still a little bit hard-coded in the sense that we have to change them a few times at the top of the contract, but they're a lot less hard-coded than they were. So I think, yeah.
And this is a simple contract. I'm imagine more complex, larger complex.
Oh yeah,
Yeah. This really cuts down.
Right? The bigger it gets, the less useful Blockly is, and the more useful well-named variables are.
Yep.
Right. If it's something that fits within a page, Blockly wins in terms of understanding. Right. And it doesn't even matter that whether you've got a little bit of duplication or whatever. But once your Blockly is 5 pages, the Haskell starts to win. And once your Blockly is 10,000 pages, it's not even possible to. So we've looked at two things. Today we've looked at kind of readability, whereas last time we looked at kind of using recursion to make arbitrarily sized contracts, So you can use those two things to kind of end up coming up with something very, very general while readable at the same time.
Yep, I like it.
Cool. Now let's quickly go to the JS editor. So I'm going to whip up something new in Blockly. What have I done?
Refresh when in doubt.
Yeah, before I refresh, I really don't want to lose this.
That's true.
I'll just paste it somewhere.
Good call.
Yeah, and then I'll I often use text edit for little notes and stuff. Cool. Okay, now we can refresh. I think it's actually not that stupid. I think it's got it anyway. We haven't lost it.
Wow. That seems, I feel like that's different. I feel like before it used to start you over from scratch.
I've noticed that it's been remembering things for a little while. Okay, so I'm gonna make like a real simple no whens, right? I'm just gonna pay make a pay sorry, party roll. Payee. Values. So this is going to complain about lots of things, basically, because it's not, and we'll just have a close there. Okay, so a payment gets made. It's not a valid contract because it doesn't require any deposits, right? So if I send this to simulator, it's going to complain, but I don't care. I just want to show you how you would write this in JavaScript.
Okay.
So we go to the JS editor. Wow, this actually, oh, right. Yeah. Sorry. Yeah. Okay.
I think you have like the zero coupon bond or something open.
Yeah. So I'm gonna leave some stuff up as an example. Yeah. So this is basically, so in Java, in Haskell, we were able to just paste, and that was valid Haskell. Here, it's a little bit more complicated. So const contract equals, and we say the type is contract equals, right? So that doesn't compile, but we can kind of make it compile with a little bit of effort. So most of the time, I think these capital letter constructors end up being lowercase names, and between every parameter, you kind of have to put in a comma. And then finally that, then close becomes close, like that. Token, like that. Roll. So yeah, like in Haskell, you call functions just with a space, whereas in JavaScript, you have to open bracket, close bracket. So there's more brackets involved.
More bracketry.
Yeah, like that. That'll be roll.
Very similar though.
Similar, like one-to-one translation, right? Anyway,
Yeah, I just was kind of interested
those.
just to kind of see a quick little demo of what you thought, kind of.
So you can look here, right? Like they've got an existing one, which is that. Like say that escrow, which is what we. So you can kind of look at, Alice is a party, and that's equal to roll Alice. Pay is a bound, and it's equal to bound 0, and then there's this choice by Alice, and then it's kind of like it's very similar, I guess. All of these things are just instead of writing Haskell functions, you write JavaScript functions, and
then they pretty much just get transferred into Haskell functions.
Or more likely they end up generating something like this, which gets processed by Haskell. But it's just another way of expressing the same underlying graph. Any language can do it. Any language that people put into the effort in of trying to do it. So look, fundamentally it can be done in any language. So my feeling is, just because of the way popularity of languages goes, like it might be worth some time at some stage spending time looking at how to do some of these things in JavaScript rather than Haskell. And that's a very difficult thing for me to say, because I'm not the biggest fan of JavaScript. I'm a big fan of Haskell, but
for a wider audience of
yeah. So what I don't know is obviously it'll take some playing with and see what the limitations of this JS editor are and stuff like that. But I encourage you to play with it.
I kind of started. I discovered it today myself, and was kind of just poking around in there, seeing what I could figure out.
You don't gain or lose any power with using JavaScript over Haskell. It's just a different way of expressing the same exact things.
Yeah, but in the end, inside of Cardano, it's always going to get run as Haskell at the end of the day.
Yes, but be aware that this code here, this code is not running in Cardano. This code is running on some computer that produces.
No. But yeah. I guess what I'm saying is, even if you use the JS editor, when all said and done in the future, I guess maybe I'm making an assumption, but all said and done in the future, that code would not execute in JavaScript on the blockchain. It would execute in Haskell on the blockchain.
But the key thing is, like, there are a few layers to it. So what would happen on the blockchain is you end up like with a Marlowe contract like that, an expanded one, not Haskell code, and then that gets translated into like Plutus, and then Plutus gets interpreted by Haskell over there. So there are a few steps, like which is why the front end language that you use doesn't matter so much. Whatever you're comfortable with. Having said that, major advantage of Haskell, at least right now, is that you can paste the things from this simulation directly into Haskell and it's going to compile.
Yeah.
And then you can slowly refactor. You don't have that in JavaScript because it's represented differently.
So you can't, in the JS editor, you can't really test it by compiling it.
Yeah, like you can compile it, but you can't paste this thing that, so you can't go Blockly, send to simulator, take that and paste, that doesn't work because it's not valid JavaScript.
Gotcha.
So the way we've been working of starting out in Blockly and then refactoring to a maintainable Haskell program, I think is still more plausible in Haskell right now. Now, if this simulation starts giving you the option to output JavaScript directly, then that's worth revisiting.
Gotcha.
Yeah.
Well, thank you very much.
Cool. No worries. So I'm going to stop recording.